So let's take a look at an example of some simultaneous equations with three equations. We do here have some constant that's a parameter that we're probably going to be able to set ourselves. So show that these equations do not have a unique solution. So as I start to solve it, I want to arrive to a place where I have my augmented matrix, but somewhere there's a row that has all zeros. And over here is another zero. So let's just get started and try to solve it. I'll put it into my augmented matrix. So I take the coefficient of the first line, and the right-hand side of the equal sign goes on the right-hand side of this line. Here I have 2, 1, 4, 6, and 1, negative 4, 5, 9. My goal is to make this triangle be zeros. So let's focus first on this second row. So as I do this change, I'm going to get a second matrix, but the first row will stay the same. I'm not going to do anything with that row. Okay, so what combination of this 2 and this 1 is going to add together to be 0? And I can see that if I do the number in row 2, subtract 2 times the number in row 1. So for example, I have the number in row 2 minus 2 times the number in row 1, that's 0. The number in row 2, subtract 2 times the number in row 1, that's 1 minus 4, that's negative 3. The number in row 2, subtract 2 times the number in row 1, that's 2. The number in row 2 minus 2 times the number in row 1, that's just going to be the expression 6 minus 2k, because k is some sort of unknown. So here I have 0, negative 3, 2, 6 minus 2k. I want to do a similar thing with the third one, because my goal is to get there to be a 0 in this location. Like this right here is going to have to be 0. So this one looks a lot more straightforward. I could just say row 3 minus row 1. That's 1 minus 1 is 0. Negative 4 minus 2, negative 6. 5 minus 1 is 4. 9 minus k is, well, 9 minus k. So in this row, I have 0, negative 6, 4, 9 minus k. All right, I got my first two zeros. Next, I want there to be a 0 in this location. I want this triangle of zeros to happen. But now I must use these two equations. I can't use the top equation, it'll ruin one of these zeros. If I do row 3 minus 2 times row 2, because like negative 6 minus 2 times negative 3, that'll be 0. Like the whole point is in figuring out what sort of multiplication and addition makes this happen. So for space, I'm going to come down here. Nothing is happening to the first row. Nothing is happening to the second row. But the third row, I am doing this subtraction and multiplication. So I have negative 6, it's the number in row 3. Subtract 2 times the number in row 2. That should be 0, that's the whole point. I have the number in row 3, subtract 2 times the number in row 2. 4 minus 4, that's also 0. And now, the number in row 3. It's a little more complicated because it's a full expression. Subtract 2 times the number in row 2. So expanding and simplifying, this is 9 minus k minus 12 plus 4k, which will be equal to negative 3 plus 3k. So this is negative 3 plus 3k. There's a solution, but not a unique solution, as long as this also equals 0. I need this to be equal to 0. Negative 3 plus 3k equals 0. 3k is 3, k equals 1. So if k equals 1, then there is a non-unique solution. Now we continue to part B. So part A1, we show that they do not have a unique solution. By getting to this 0, 0, 0, that's already a problem. We know we don't have a unique solution. Part 2, find the value of k for which the equations are consistent, which means there is a solution, it's just not unique. So as long as this also equals 0, there is a solution, it's just not unique. So as long as k equals 1, there will be a solution. So then for part B, let's let k be equal to 1. That brings our system down to just these two equations. So this means we have x plus 2y plus z is 1, because k is 1. and negative 3y plus 2z is 6 minus 2, that's 4. Again, because k is 1. Since this one doesn't have an x, it's really going to be easiest if we just define either y or z to be whatever parameter. So let's say that we let z be lambda. That means this bottom equation becomes negative 3y plus 2 lambda equals 4. So just rearrange this to solve it for y. Y equals 4 minus 2 lambda over negative 3. So that will be, I'd like to pull this up. So 2 lambda minus 4 over 3. I was just getting this negative by distributing it into the numerator. So now I have z. If z is lambda, then y is 2 lambda minus 4 over 3. And what will x be? Well, I have x plus 2 times y, which is 2 lambda minus 4 over 3, plus z, which is just lambda, equals 1. So x plus 4 lambda minus 8 over 3 plus 3 lambda over 3 equals 3 over 3. I'm just getting a common denominator to make my life easier. So then x is going to be equal to, these together make 7 lambda, so negative 7 lambda. When I add 8 to the other side, that'll be 11 over 3. So my solution is, if z is lambda, then y should be equal to 2 lambda minus 4 over 3, and x should be equal to negative 7 lambda plus 11 over 3.